Okay, we're recording. All right, so that said, let's go ahead and I just have a couple equations here. So let's do aluminum hydroxide plus hydrochloric acid. You'll typically see these as acids and bases. It's going to go to aluminum chloride plus byproduct is going to be water. So this will be a very classical way to express the titration reaction of if I have a certain solution of this, certain molarity of this, how much of this, and I don't know this, and I calculate again, if this is A, this will be B, or if this is A, this will be B. Okay? So we've got to balance the chemical equation, and when I do that, I get 3 here, 1 here, and 3 here. Okay? So this is the ratio that actually becomes important. So in my example that I did, I have 0.25 molar solution of hydrochloric acid. Calculate the milliliters of this. How many milliliters will react with 0.386 grams of aluminum hydroxide? Okay? So one of the things I need to know, and what you'll see with these, I actually think these are a little bit easier to do than grams A, moles A, moles A, moles of B, moles of B, grams of B, because I don't have to calculate the molecular weight of hydrochloric acid because it's already there. So maybe that's easier for you, maybe not, I don't know, but we'll work through the dimensional analysis of how we actually get to this conclusion. What I do need is the molecular weight of aluminum hydroxide, and when I added it up, it is 78.0 grams per mole. Okay? That's the molecular weight or formula weight of aluminum hydroxide. So the question's asking how many milliliters of a 0.250 molar solution of hydrochloric acid will react with 0.386 grams of aluminum hydroxide. Okay? So we're doing solution reactions here. This is basically what a titration is. Right? How many grams are going to react with this? Well, a couple different ways that I can approach this. One, I could set it up with the grams, or I could set it up with the molarity. I'm going to set it with the grams because I know my grams here. So I'm going to set it up in my dimensional analysis as 0.386 grams of aluminum hydroxide. Whoa, check that out. I'm going to make a big, long equivalency here because I know I'm going from grams of A to moles of A. Moles of A to moles of B. Moles of B to molarity of B. Okay? Those are all equivalencies. So I'm going to have 3 equivalencies. Okay? And this is going to look very similar to what we've already done in our stoichiometry from chapter 3. So down here, I'm going to have grams of aluminum hydroxide. Here, I'm going to have moles of aluminum hydroxide, which means I'm going to have moles of aluminum hydroxide here. And moles of hydrochloric acid here. Okay? Oh, and I also know something right here. I have moles per liter, don't I? What is the definition of molarity? Moles per liter. So it's either liters per mole or moles per liter. Again, it's an equivalency. What drives the direction is going to be what's on top here, because that has to cancel here to leave me with liters. Okay? Question asks milliliters, so I do have one more step. You can add that here if you want, by the way, and you could do this if you want it to be complete. There you go. Okay? Now let's walk through it before we just plug and chug. Do we see what we're doing? We are calculating how many grams of aluminum hydroxide are going to react with this molarity of hydrochloric acid. So I've been given the number of grams of aluminum hydroxide, therefore grams and grams. Moles, I know that through the molecular mass. Moles, here's my stoichiometry, here's my molarity, and here's my conversion from liters to milliliters. Isn't that kind of fun? So it all sets up very logically, very consistent with what we've already done with our stoichiometry. So now we get to go in and plug everything in and make sure everything cancels out. So I know 3.86, so that's been given. What's the 1 mole of aluminum hydroxide? Weighs 78.0 grams. My stoichiometry is a 1 to 3. Okay? My molarity is 0.250 per 1 liter. Does that make sense? It's the molarity, moles per liter. Okay? And I know 1 liter is 1,000 milliliters. Any questions on that? I think that should be pretty straightforward setting that up. On Wednesday, I kind of broke them down just so you can see the logic of it. This is putting it all together in more of what we've been doing with our dimensional analysis. So I'm going to take 0.386. I'm going to divide that by 78. I'm going to multiply that by 3. I'm going to divide that by 0.25, and I'm going to multiply that by 1,000. And lo and behold, I get out 59.4 milliliters of HCl. Will completely neutralize that. Does that make sense? Is that kind of fun? No, it's not fun? I think it's fun. It's kind of cool. It's kind of satisfying. All right. Questions? Where did anything come from? Make sense? Because here's what we're doing. You're going to get tired of me hearing this. You're tired of me hearing this. You're going to get tired of me saying this. I get tired of me hearing this. Grams of A, moles of A. Moles of A, moles of B. Moles of B, molarity of B. Molarity of B, milliliters of B. Okay? So that's where you are on the roadmap. Nothing has changed. We've just added molarity as an off branch, as another arrow off of this. Okay? Okay, you ready to do one? Let's try another one. See what we get. Maybe I'll use it on the other board. Move myself over here. Okay, let's try another one. Let's see if, let me draw it up here, and then you see if you can set it up, and then we'll work it together. So in this one, I've got barium chloride. So I've got barium chloride plus aluminum sulfate. Ooh, I can already see how I could make this a word problem. Neutralizes to aluminum chloride plus barium hydroxide. Oh, barium hydroxide, that sounds like a precipitate to me now that I'm an expert with precipitations. Okay, so this one says calculate the molarity of barium chloride if 25.29 milliliters of milliliters. Oh wait, hold on. This is actually tetra. So molarity of 25.29 milliliters reacts with 0.231 grams of aluminum sulfate. Okay, see if you can set that up. What is the molarity of the barium chloride solution if 25.29 of it, milliliters of it, neutralize 0.231 grams of aluminum sulfate? Okay?
What is after AL? Is that
AL, well, it should have been a 2. That's my dyslexia coming in. Thank you. I get my 8s backwards all the time. That's kind of funny.
I did the exact same thing. Did written it down and I just didn't notice it was wrong.
It was a 2, right? Yeah. Now you have mild dyslexia. My brother has severe dyslexia. You knew what I was saying. You knew what I was saying.
I read it exactly how you
Right,
told
right. That's what I meant, right? That's what my brain thought. Because first thing you want to do is make sure you balance it. That one's not balanced, so. Anybody watch the game last night?
Yeah.
I'm a diehard Dodger fan, but I think San Francisco got hosed. I'm not gonna lie to you. It looked like his arm was running off. You got what you'd say?
He definitely did not.
He didn't swing. I don't think he swung.
I think it's wrong.
Who did? Are you a Dodger fan?
Yep.
Yeah. Like I said, I was a diehard Dodger fan. I was so excited that I didn't go. Anything went wrong on that one. I'm glad they went wrong. Don't get me wrong, but I do.
It's always nice.
Amen.
Yeah, and then that's a 1-2. Two chlorides. That is 6 now. And then the area or
Get the time to buy it.
Okay, when we set it up,
Yeah.
now see if you can set it up right, and then we can work the problem together. So we've been given grams. So this is going to be A. So grams of A, moles of A, moles of A, moles of B, or milliliters of B. Okay, then we calculate the molarity of B. So I'm going to start with setting up the equation. I've got 0.2310 grams of aluminum sulfate. Okay. Which tells me I'm going to have to go through moles, so I'm going to go grams of aluminum sulfate. Moles of aluminum sulfate. Moles of aluminum sulfate. Moles of whatever my reactant in, in this case it's barium chloride. Okay, boom. Now, I've got moles of barium chloride, right? What is molarity? Moles per liters. So somehow I need to have liter down here, right? So how do you think I'm going to do that? Well, I'm going to go ahead and go 25 point, or let's go milliliters of barium chloride, okay, down here, which means that over here it's moles per liter, so I'm going to have liter per milliliter. Oh, that's kind of cool, because it's moles per liter, not milliliter. I've been given milliliters. Does that make sense? So that should be the way it sets up. Everything should cancel if we do it right, and we should get moles per liter out in the end. Grams of aluminum sulfate, grams of aluminum sulfate, that'll cancel. Moles of aluminum sulfate, moles of aluminum sulfate, that'll cancel. Moles of barium chloride, milliliters of barium chloride. Oh, that's not going to cancel. I don't want it to cancel because I want to be left with moles. So good, moles are going to stay. So milliliters, I don't want milliliters, I want liters. So milliliters of barium chloride, milliliters per liter. Does that make sense? So in the end, if everything crosses correctly, I should be left with moles per liter, and I will be. Does that make sense? So I haven't plugged anything in yet. All I've done is set up the equation. Any questions before we start to plug and chug? Ready to plug and chug? See what we get? Okay, let's balance this thing. How many barium chlorides do I need? How many aluminum sulfates do I need? What is this one? 3, good. And 1. That's all I need. You can balance it. What else do I need over here? 2, 3, good. Okay, you don't need those, but nonetheless, we're working over here. This is where our A and B is. So, here we go. 1 mole of aluminum sulfate. I calculated out, if I did it right, it's big, 342.16 grams. Over here, I know that my stoichiometry is a 1 to 3. Here, I know how many milliliters of barium chloride I use, and that's 25.29. And I know that 1,000 milliliters are in 1 liter. Okay? Any questions on that? Okay, let me run through my calculator and see what we get. So I get 0.231 divided by 342.16 times 3 divided by 25.29 times 1,000, and it equals a, lo and behold, 0.0800 molar solution. Yeah, that's kind of cool. Okay, 0.008 molar solution. Isn't that fun? It's a pretty dilute solution, actually. All right. So here, this is how they actually do calculate the molarity of an unknown, like I was talking about with like sodium hydroxide in the potato factory or whatever. They take an aliquot out, they titrate it in, they get this many milliliters, they can back calculate the molarity of the sulfuric acid in the vat. Okay? So that's a classic titration. One more before you do yourself? Okay, one more. Okay, let's do, I have a third one. We're still going? We're still going. I'm gonna move myself over here. Okay. Any questions on that? Sorry, just shout it out. Okay, so this one, okay. For this one, we've got iron. I'll just balance it so we don't have to waste time balancing it. 3 iron carbonates plus 2 phosphoric acids goes to iron. Ooh, this is a gas generating one kind of pill, not that that matters for us. Plus 3 carbon dioxides plus 3 watt trees. Okay, So in this particular neutralization reaction, we want to calculate the grams of iron carbonate that will react with 60.00 milliliters of a 0.250 molar solution of phosphoric acid. Okay, set it up. How many grams of iron carbonate will react with 60 milliliters of a 0.250 molar solution of phosphoric acid? Ask yourself where you are on the roadmap. It's a little bit different, so just make sure you're navigating the roadmap. Okay. See a few pencils down. Hear a few calculators clicking. We good? Can we work it?
Yeah.
Work it together? Okay, let's talk about the roadmap before we just jump in. All right. So this is my unknown. So this is going to be grams of B, which tells me this is going to be A. But notice I don't start with grams of A. I start with moles per liter of A. Okay. So I'm moles per A, moles to B, grams to B. Okay? So I'm down on the lower left of our roadmap. I'm not up at the top, I'm down on the lower left. I'm in moles. I've already got moles of A. I just have to figure out how many moles, because that's telling me how many moles it is. So I want to start with this number. So in my dimensional analysis, my dimension analysis is going to be set up this way. I'm going to have 0.25 moles of phosphate here, and that's going to be per 1 liter, right? Moles per liter. That's what that's telling me. So how then do I determine how many moles I actually have? Well, I have 60 milliliters, right? So I have moles per liter, so how many milliliters do I actually have? 60, right? So somehow I have to go from moles per liter to calculate moles. So how am I going to do that? Well, do I have a full liter?
No.
How much do I have? Okay, so how do I set this up in order to get that information out? Do I multiply it by 60 or do I divide it by 60? What? You guys help me. Why do I divide it? Do I want my milliliters to cancel?
Yes.
Is that going to work? 100?
Could you do like, you have 0.25 moles per liter. Then you can cancel out the liter units with milliliter units, so you divide out the liter unit with the 60 milliliters.
Okay.
So if you convert the liter to milliliters.
Convert to milliliters to liters. Yeah.
Then you have a fraction of.
Boom.
Multiply that fraction by the moles.
Fine. Well, somehow I have to get rid of this and whatever's up here. Does that make sense? So what you're saying is I can just convert this directly to liters, which would be 0.06 liters, which is going to do it for me. Okay? Or what else I could do is I could leave this in milliliters, convert this to milliliters, or I could have a second box that's milliliters to liters. There's several ways to do that. Okay? I think the more you work these, you're going to be going back and forth between milliliters and liters very quickly. It's just a fraction of 1,000. That I put it in over there just to show you how that actually works. So all I did was convert the 60 milliliters into liters. Now my liters is going to cancel out. Okay? We good? So now I'm at moles of A. What's my next step? Moles of B, going across my stoichiometry. So now I'm going to put moles of phosphoric to my stoichiometry of moles of what I'm neutralizing, which is my iron carbonate, iron 3 carbonate. Okay? But now I'm from moles of A to moles of B, but I want to get to grams of B. So getting to grams of B, here I have to go moles of iron carbonate to grams of iron carbonate. So everything was done correctly in my dimensional analysis. Everything should cross out and I should get grams of iron carbonate. So I've already canceled my liters. Moles of phosphoric, moles of phosphoric, moles of iron carbonate, moles of iron carbonate. I'm left with grams of iron carbonate. It's exactly what the question was asking. Okay? So again, as long as you navigate these on the roadmap, I think you're going to be fine just thinking through how these go. Okay? So let's go ahead and plug in the numbers and see what we get. So 0.25 liters. What's my stoichiometry? It's going to be a 2 to 3. I didn't do that. What's iron carbonate weigh? Here we got it.
115.8.
115.8. Thank you. Okay, so now if I take my trusty dusty simple cheap calculator, I go 0.25 times 0.06 times 3 divided by 2 times 115.8, and that equals 2.6. And how many significant figures? I'm in 4. So that equals 2.60. It's an even number, so we leave it. That's a good rounding one there, by the way. Hey, why don't you guys try it? That's what it is, but I need to round it there. So do I round it up or do I keep it the same? Up? No. Really? How many say up? How many say keep it the same? How many still don't know how to do this? Okay, so when it's 5, okay, I go to my 5 and I look to the next one over. What is it? Odd or even? Even, therefore it stays the same. So it becomes that. Yes?
Isn't the sig fig 3?
It's this one. This should be a 0. Yeah, thank you. It should be this one.
Okay.
Yeah, it should be 4.
Okay.
Titrations typically go to 4.
Okay.
Yeah, they're really precise. The ones, and even in lab on Tuesday, when we're doing vinegar, we'll actually take that to 3, I believe. Okay, good. Again, it's just one more step of the roadmap, and now you can say how many molecules. Wouldn't that be cool? Wouldn't that be fun? How many molecules of iron carbonate will react with 60 milliliters of a 0.25 molar solution of phosphoric acid? Right? What would you do? What would you could do it. How many molecules? I'm just going to have one more thing here. 1 mole is 6.022 times 10 to the 23 molecules. It's not that hard, and it all should, hopefully it all, 1 mole should cancel out, and we're left with, if I did it right, okay? So again, this roadmap just keeps on going. It's like a never-ending roadmap. All right, your turn. You've seen me have enough fun for one day. Let's okay, so there's a couple different, on this, there's a couple different styles. There's a couple just calculating the molarity super quick, and then down here are more like this, okay? So I'm gonna just do a couple of these and then jump down to the more complex ones because we have about 15 minutes. But I definitely would finish this because this is, if you're good with this, you're actually gonna be good with chapter 3. This is the heart and soul of, sorry, chapter 4. And it is due, what, tonight?
Yeah.
Okay, so let's focus on 1, 2, 5, and 6 for now. Okay, 1, 2, 5, and 6. It's just English and how I